And we're back to 16-2, concentrations of solution, where we're wrapping up our discussion on dilutions. In example number 8, it says if 60 milliliters of lithium chloride solution is diluted to 150 milliliters, and the new concentration is 0.85 molar, what was the original concentration of lithium chloride? So, again, you're doing a dilution. So start off with M1 V1 equals M2 V2. Do we know the original concentration, M1? No, the question says, what was the original concentration? So, we're going to write that as a variable. V1, the original volume, is, well, we're starting at 60 and diluting to 150, so the original was 60 milliliters. The final concentration, it says, is 0.85 molar. And the final volume is 150 milliliters. And so now all we need to do is solve. So we divide both sides by the 60 milliliters. Of course, the milliliters units divide out over here. These entire terms divide out on that side, and therefore M1 will equal 0.85 times 150 divided by 60 divided by 60, and that should be 2.13 molar lithium chloride. So there you go. The diluting prelabs we'll be tackling together in class, so we can go ahead and skip over that, as is Beer's Law. That will be another lab that we do where we determine an unknown concentration. But another way that you can express concentration as opposed to molarity is by a percentage. But there's two ways you can do that even. The first way we want to talk about is the percentage by volume. In the percentage by volume, which is expressed as a percent sign with volume over volume, is simply the volume of solute per volume of solution made. All right. What volume of the total solution is a particular solute, or is a particular solute? All right, so let's go ahead and try one of these problems, and maybe that'll make sense. Let's go ahead and change up colors. Let's go with red here, just for the heck of it. What is the percent volume of ethanol in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 milliliters with water? So again, your percentage by volume is going to equal the volume of the solute, which in this case was 85 milliliters, divided by the total volume of the solution, which is 250 milliliters, times 100%. Of course, the milliliters units divide out, and the only unit that you're left with is the percent sign. And 85 out of 250 is going to be 34%. So we would say that that solution is 34% ethanol by volume. All right. Try another. A bottle of antiseptic hydrogen peroxide is labeled 3% by volume. How many milliliters of peroxide are in a 400 milliliter bottle of this solution? So, once again, we know that the percentage by volume is going to equal the volume of solute per volume of solution times 100%. So now just plug in what you know. Well, we know that the percent volume is 3%. We do not know the volume of the solute, so we'll just put X for that. The volume of the solution is 400 milliliters. And then, of course, you got to multiply by 100%. Since we have two X's here, let me just go ahead and switch this to, I'll just say volume of peroxide. There we go. And now we just simply need to solve for the volume of the peroxide. So we're going to divide both sides by 100%, course, the percent signs cancel out. We're going to, and then these two 100% divide out. We're going to multiply by 400 milliliters on both sides. Okay, these divide out. So what you're left with is the volume of your peroxide in the bottle is going to be 400 milliliters times 3.0 divided by 100. Don't worry about that last zero there. 400 divided by 100 is going to be 4. 4 times 3 is 12. So that's going to equal 12 milliliters of peroxide in the original solution. All right. Now the other way that you can express concentration is by mass, and sometimes that's a little more useful way of doing it. Let's go ahead and do this in blue. The percent mass will be similar. It's going to be the mass of the solute divided by the mass of the solution times 100%. So if you want to make 2,000 gram a 2,000 gram solution of glucose in water that has a 2.8% by mass, or that is 2.8% by mass. So how much glucose should you use? There should be a period right there. And then how much solvent should be used? Well, first of all, you know that this is going to be 2.8% by mass, and that's going to equal some mass of glucose over 2,000 grams of solution. It's the mass of the glucose over the mass of the solution times 100%. So let's go ahead and solve for the mass of the glucose. Of course, we're going to divide both sides by 100%. So that the percentage signs divide out over here. These entire terms divide out. We're going to multiply the 2,000 grams over to the other side. These entire terms divide out. And what you're left with is the mass of the glucose equaling 2,000 times 2.8 divided by 100, which equals 56 grams of glucose. GLU, short for glucose. So therefore, we know that we need 56 grams of glucose. That's the first question. But now the second question says, how much water should be used? Well, we know that you have 2,000 grams total, and if 56 of those grams is the glucose, then that must mean that the remaining 1,944 grams must be our water. So what you're going to do if you wanted to make 2,000 grams of 2.8% glucose solution by mass, you would take 56 grams of glucose, you would take 1,944 grams of water and mix them together. In the next podcast, we're going to take a look at an extra section that's not necessarily in the red book that deals with solution stoichiometry. We'll see you next time.